Today we will study binary search trees. A binary search tree is also known as a binary sorted tree. Let us read the definition of a binary search tree. It states, a binary search tree is a tree if each node n is such that the value at n is greater than every value in the left subtree and is less than or equal to every value in the right subtree. To understand this, consider a small tree just having a one root and one child node on the left side and one child node on the right hand side. It has three values. 38 is placed at the root node, 21 on the left hand side is the left child node, and 45 is on the right hand side. Because 21 is less than 38, so 21 is placed on as the left child node, and because 45 is greater than 38, it is placed on the right hand side of the 38, and therefore it is a binary search tree. Let us take a bigger example of a binary search tree. In this tree you can see yourself that all nodes on the left hand side of the parent node are smaller than the value at the parent node, and all the child nodes on the right hand side of the parent node are greater than the value at the parent node. This is verifiable for any node that has a child node. For example, 45 you can see it has two child nodes. 39 is the smaller value, so it is on the left hand side, and 56 is the larger value than the 45, therefore it is placed on the right hand side. Now, how to create a binary search tree when a list of random numbers is given? Consider the following list of random numbers. We will show you: 23, 35, 80, 2, 13, 56, 11, 60 and 71. Now start taking numbers from the left hand side of the list and start creating a binary search tree. First one is 23. We take 23, create a root node with the value 23. We'll take the next value, which is 35, compare it with 23. 35 is larger than 23, so we place it on the right hand side of 23. Next is 80. Compare the 80 with 23. It is larger than 23, it will move on the right hand side. So we find that another node is already placed there. So we'll further compare it with the 35. It is still larger than the 35, so we'll move it on the further right of 35. Now we place it as you can see in the video. The next number is 2. We take 2, compare it with 23. 2 being smaller than 23, we place it simply on the left hand side, as per the rules of a binary search tree, that the node having the smaller value is placed on the left hand side of the root node. The next number is 13. We compare it with 23. 13 is smaller, so we move to the left hand side of 23. We again compare it with 2. 2 being smaller than 13, that is 13 is larger than 2, we move it to the right hand side of 2. The next number we take is 56. We compare the 56 with 23. We find 56 is greater than 23. We move to the right hand side. We compare 56 with 35. It is still larger than 35. We move further right hand side of 35. We find another node. We compare 56 with 80. Now 56 is less than 80, and therefore the lesser value will be placed on the left hand side of the compared root node. The next number is 11. Now we compare 11 first with 23. It's smaller. we move to the left, compare 11 with 2. 11 is larger, therefore we move it to the right hand side of 2. We find that already another node is there, 13. We compare 11 with 13, and because 11 is smaller than 13 and the left hand side of the 13 is empty, so we place 11 at the left node of 13. The next number is 60. Keeping in mind the rules that we have been following for inserting the nodes in a binary search tree, start comparing it with the root node. 23 is smaller, we move to the right hand side. 35 is smaller than 60, we move further right. 80 is larger than 60, and therefore we move to the left hand side of 56, but we move to the left hand side of 80. You find that another node is placed there having the value 56. So you compare 60 with 56 and we place 60 towards the right child of 56. Our last number is 71. We repeat the same process, compare it with 23, move to the further right, compare with 35, move to the further right, compare it with 80, 71 is less than 80, so we move to the left hand side of 80, we find another node, 56 placed there, compare 71 with 56, 71 is larger than 56, so move to the right hand side, but still there is one node placed already there, so we compare 71 with 60 and we find that 71 should be placed at the right hand side because 71 is larger than 60. So with the given list of the numbers, we have created a complete binary, we have placed a binary search tree. So we have learned a binary search tree being formed from a list of given random numbers.